Good morning, everybody. First, I'd just like to start by saying thanks to Nuala and the task force for the invitation today to speak with you. So just a little bit of background about myself. So my name is, as Nuala said, is Graham O'Neill. I'm a food scientist by training from the School of Food Science and Environmental Health in TU Dublin, and my expertise would be in the area of food ingredients and food chemistry. And really the focus of the talk today is about how we can collaborate with industry partners and to accelerate and to guide or deepen knowledge in the area of food reformulation. So just in terms of the approach that we would often take in projects with food companies, so at a high level, we would typically start with the scientific literature to make sure that we have all of the available knowledge, that we're not reinventing the wheel. We would then go into the characterization of the food products, so quite a detailed characterization, so we have an accurate benchmark in terms of the parameters of the product that's acceptable, and to make sure that we don't vary too much from those characteristics as we reformulate the food product. And then the third step is the reformulation effort itself. Quite often the reformulation can focus on a specific aspect of a process. It can look at the product from start to finish, but it can also be reformulation in conjunction with another part of a project. Maybe it's a new flavor, maybe it's a different type of texture that the food company is looking for. So if we go through each of those steps in a little bit more detail, okay, so we typically start off with the lit review to make sure that we can leverage all of the available know-how that's present, and it's not every food company that has access to the breadth of the scientific literature that's available. So if we use cheese for an example, okay, so just looking through Science Direct, so there's 184 original research papers that look at fat reduction in cheese, and there's 115 papers that closely match salt reduction in cheese, okay? If we focus on the fat papers, okay, so two of the papers that I suppose can be quite advantageous in a reformulation effort. So there's a paper there by Mary Ann Drake that looks at the impact of fat reduction in cheddar cheeses. So as the fat content reduces, what that paper observed was that as the fat content goes down, some of the compounds are consistent across all the different types of fat levels, okay? But there is a concentration effect. However, there is also a change in the biochemistry of the cheese as the fat content changes. So there are some compounds that are present in low-fat cheeses that aren't present in high-fat, and then there are some in the high-fat cheeses that aren't present in the low-fat. And the ambition or the benefit of having knowledge like this is that we can relate this information to an existing product and use that to guide the parameters of a reformulation project to help shorten the duration of the project, to guide it so that we're quicker to achieving success. A second paper that could be of interest from a reformulation project is the paper by Rogers. So they look at cheese from 33% down to 3%. And they look at the texture of the cheese, and essentially what they observed was that at 10 degrees, there was a big difference in the texture of the cheeses as fat content varied. And again, we can use this to guide reformulation projects, because essentially it can tell us that cheeses at a certain fat content will withstand processes such as slicing or grating, but there could be a minimum point at which the structural integrity of the cheese becomes too weak, and it's no longer viable. It might be viable for use in the home, but it mightn't be viable for processing at an industrial scale for the production of a grated cheese. So the ambition is always to try and leverage as much of that know-how as possible to inform a reformulation project so that we don't reinvent the wheel and we accelerate the duration of a research project. The approach that we take, okay, is typically one of the key strengths of the university is around the characterization of a food product so that we have an accurate benchmark, and so that the reformulated product varies as little from the original as possible, with obviously the exception of the salt, sugar or fat being reduced and hitting the target. So some of the work that we might do, so in the area of viscosity or rheology, we could look at in beverages, for example, as we try to reduce the viscosity, or as we try to reduce the sugar content of a beverage, that we can measure and make sure that we minimize the change in mouthfeel of a beverage. Or in the case of yogurt, if we're trying to reduce the fat content or the sugar content, how are we affecting the gelation of the yogurt in the first place? Are we going to produce a yogurt that has the same body, the same texture? How will that yogurt deform? So when the consumer puts the spoon in, is it going to deform in the same way? Is it going to have the same body? And when it passes over the tongue, is the consumer going to get the same level of creaminess despite the fat content being reduced? From a texture point of view, so we can do studies like fracture force analysis. So if you're trying to reduce the fat content of a biscuit, for example, if you're changing the fat type or if you're reducing the fat level, Is the fracture force going to decrease? Is the biscuit going to become too soft? And is that going to alter the acceptability of the product to the consumer? We can do work on particle size analysis and food structuring. We can do quite a lot in the area of sensory, so we have a food processing hall attached to our sensory suite. We can do simple tests, so anything from triangle geometry tests to more complicated descriptive sensory, so looking at the check all that apply technique or temporal dominance of sensations to get more descriptive feedback, and we can partner that with analytical techniques such as GCMS for volatile analysis of a food product. One of the important attributes of reformulation can be shelf life. So we can look at water activity, for replacing salt or sugar. How does that affect, the microbial load of the food product to make sure that you maintain the high safety standards of the product in the reformulated version. And then we can also do nutritional analysis of the food product itself. The approach that we take is typically quite collaborative, so the industry partners will be very much heavily involved and contribute their knowledge to the projects. They tend to be short-term, so quite short in terms of kind of 2 to 6 months, really. And we try to leverage all of the available supports, so whether they're the likes of the Enterprise Ireland Innovation Vouchers, so that the reformulation effort and the collaboration tends to be very cost competitive for the industry partner. And in the process, we would typically start off with our new formulation or a recipe that's informed by the scientific literature and all of the available know-how. We would then characterize that, we do sensory on it, and ultimately the aim is to reduce the number of iterations of that cycle that we have to do to make sure that the product is as close to the original, but reformulated as desired. So some of the examples of the types or the possibilities of analysis. So this is all published work. It's not my own. The work that we tend to do with industry tends to remain confidential, so I don't want to present that today. But this is just an example of some of the type of work that could be done. So this is a reformulation of a bread type product. So what you're seeing here, the top row is a 0% salt. The bottom row is a 2% salt. And then you're seeing 4 different time points, 0, 2 minutes, 6, and 20. And the important thing here is the yellow, so you can see the gluten here, the protein matrix at 0 minutes. Essentially, the protein is intact, it hasn't unraveled. And as the mixing time continues, we're starting to see an elongation of the proteins and the formation of a lovely 3-dimensional network at the 20th minute. And reformulation projects don't necessarily have to be a brand new product. What they can focus on is trying to get more detail around a specific aspect of your process. So in this case, you might be keen to understand how a reduction in salt impacts your mixing time. Do you need to mix for longer? Do you need to mix at a lower speed? So it can be used, so these projects can focus on providing more detail on a particular part of your process and to make sure that you're making an informed decision in your reformulation. In terms of beverages, we can look at the viscosity of an existing beverage. We can look at the viscosity of different types of sugars. And we can also look at sweeteners and different types of polymers and how combinations of those 3 can be used to reduce the sugar content, but to give the same mouthfeel or the same texture to the beverage as currently exists. And then we can do that in tandem with sensory analysis, so that the mouthfeel, but also the taste is still acceptable to the consumer. And then the last example is just going back to that paper by Roger. So what you're seeing here, the top, so the A and B is at 10 degrees and the C and the D is at 25 degrees. And what we're seeing is that as the fat content decreases from 33 down to 3%, at 10 degrees, there's a big difference in the structural integrity of the cheese. So as the fat content decreases, the cheese becomes weaker. And as I had said, that will impact processing, so such as the likes of slicing or grating of a product. Whereas at 25 degrees, that difference is not significant. So from an oral processing point of view, from a consumption point of view, the likelihood of the reformulation is to have a different impact than what you would see if you're trying to slice or to grate that product. So they're just some examples of the type of work that we can do. If that's of interest to anybody, or if there's any interest in partnering on a reformulation project, I'm here for today. And that's also my contact detail if anybody wants to get in touch. Thank you.